All right, in this video, we're going to look at the concept of the mole. This is a super important concept in chemistry. I cannot emphasize enough that you have got to understand the mole to be able to basically continue on for the rest of the year. Especially in Module 8, we will be using this a lot. So please take extra time here in Module 7 to make sure you understand this before taking a break for Christmas. Okay, so you should think of a mole similar to the way you think of the word dozen. Okay, the mole is a unit of measurement that symbolizes a number. Okay, so whenever you hear someone say the word dozen, you probably automatically think of the number 12. All right, so for instance, if I have 2 dozen of something, I have 24 of something. Okay, I have 2 12s. The mole is the same way, only the mole represents a really big number. So every time you hear someone say, I have 1 mole of something, what that equals is 6.02 times 10 to the 23rd of whatever it is you have. But realize that's 602, then 21 zeros after that. So that is a huge number. So the reason you haven't ever heard someone say, oh, I have a mole of paper, here is because I think literally you could cover the earth like multiple times with a mole of paper, like sheets of paper. We don't refer to the mole on a regular basis because the things we deal with in life, in our normal everyday life, are so big, we don't need to measure them in moles. I wouldn't say I have a mole of paper here. I would say I have a dozen sheets of paper. Okay, but it's the same idea, is when you have a mole of something, you have 6.02 times 10 to the 23rd pieces of it. So why is this important in chemistry? Well, in chemistry, we're dealing with atoms. Okay, so think about how small atoms are. Look at the tip of your pencil even. Okay, or the tip of the pen. Think about how many billions and billions and billions of atoms are needed just to make up that itty bitty tip of your pencil or pen. So in that case, instead of trying to count atoms, it's way easier to use the mole to measure them. Okay, so when I say I have 1 mole of atoms, it means I have 6.02 times 10 to the 23rd atoms. All right, now what we're going to try to do here in this video is relate the mole to mass, specifically the mass found on the periodic table. So remember that number, hopefully that's in focus for you, at the very bottom of the periodic table is the atomic mass of something. So like here with lithium, I'm trying to get in focus, but it's definitely not. Lithium is 6.94, okay? So that atomic mass, if it's an AMU, it tells me the mass of 1 atom. Okay, so lithium, for instance, if you look at the periodic table, lithium's atomic mass is 6.94. So if I have 6.94 AMU, that's the mass of 1 lithium atom. All right. However, this is the really important one right here. I cannot emphasize this enough. If I put the atomic mass in grams, that gives me the mass of 1 mole. So 1 mole of lithium is 6.94 grams. Okay, so now all of a sudden I have a way to measure moles of lithium using a scale, grams. Okay, so let's just take a look at the periodic table. I would highly encourage you to get yours out at this point. Okay, you're going to need it for solving the problems we're about to do together, but go find carbon. Okay, so if you go and you find carbon, okay, carbon, it says 12.0. So that means 1 mole of carbon is 12.0 grams. And this is so useful to us, okay, because in reality, we don't have a scale that's going to measure atomic mass units, okay? And in reality, you're never just going to have 1 atom of lithium, okay? Now, someone in a lab somewhere might, but we are not going to. It is much easier for us to deal with moles. So if we had carbon and you weighed out 12 grams of it, you would know that you had 1 mole of carbon, which means you had 6.02 times 10 to the 23rd atoms of carbon. All right? And what's really cool is this is a conversion factor. 1 mole of carbon is 12 grams of carbon. Okay? And that's true for any number on the periodic table. Okay? All of those atomic mass tell you the grams in a mole. So let's look at example 7.6, okay, in your book. And example 7.6 is on page 260. Says how many moles of fluorine. So it says how many, so I want to find moles of fluorine exist in a 50-gram sample of fluorine. Okay. Okay, so the question is, if I have 50 grams of fluorine, how many moles of fluorine do I have? All right, so this is not too hard. I'm going to solve it the way the book does it, okay? They're talking about fluorine, I guess, by itself here, not the diatomic fluorine. So we're going to solve it the way the book does so you can follow along, okay? So I encourage you to write first what you want to get, what you have over here. So in this problem, I have 50 grams of fluorine, and I want to change that to moles of fluorine, okay? So we're just going to treat this like a conversion factor. On the bottom goes what we want to cancel. When I want to cancel grams of fluorine, because I want to cancel out these grams, and I want to change to moles of fluorine. Okay? So the question is, how do I know how many grams and moles go together? Well, that's where the periodic table comes in. Remember, it is your best friend. It's going to be your best friend here in Module 7. It's going to be your best friend in Module 8. So keep it handy. Okay, so go over to the periodic table, find fluorine. It's hard to read here, but it's 19.0. So what does that mean? The 19.0 is the grams, just like the 12 was the grams here. So I put the 19.0 with the grams, and that's how many grams by definition. The atomic mass in grams is the mass of 1 mole. So a 1 goes on top of my problem. So 50 grams of fluorine, and I know for every 1 mole of fluorine, it weighs 19 grams. Okay, so I'm going to multiply across the top, divide across the bottom. So basically you're doing 50 divided by 19.0. 50.0 has 3 sig figs, 19.0 has 3. This 1 is a counting number, so it doesn't count towards your sig figs. So the answer is 2.63 moles of fluorine. All right, let's look at this one. This is one I just made up. What is the mass of 1.82 moles of water? Okay, and usually when it says what is the mass, that means what are the grams of 1.82 moles of water. Okay, so I have 1.82 moles of H2O. Okay, and I want to know how many grams that represents. All right, so I'm going to set up my conversion factor. That's a multiplication sign. All right, so moles on bottom this time because that's what I'm canceling. Grams on top. Okay, now the question is, where do I go to find grams of water? Well, the grams come from the atomic mass on the periodic table. But wait a second, I can't just go look up water on the periodic table. Oh, there's no water on there. There's H and O, so I'm going to have to add them all together to find the grams of water, just like what you did when you found the molecular mass. So I've got H and O. I've got 2 H's and 1 O. Okay, if you go look up H on the periodic table, it weighs basically 1.01. Multiply that by 2 is 2.02. And oxygen weighs 16.0. Okay, so, and since this is a 0.0 and I'm adding them, I'm basically going to drop this 2 for sig figs. So 18.0 grams. Okay, remember doing that? I taught you that in the molecular mass video. So water, because it's a compound, H2O, I can't just go to the periodic table and look at it. I have to look at the H and the O, and then I have to add them together. And remember, there's 2 H's, so it's 18 grams. So here, the 18 goes on top, and then the 1 mole goes on bottom. Because remember, the atomic mass in grams is always the mass of only 1 mole. Not 2, not 3, not 7. It always goes with 1. So my problem ends up being, I'll try to separate this out down here. My problem ends up being, I have 1.82 moles of H2O. I'm going to multiply that by 18 grams per 1 mole. So every mole weighs 18 grams. So in my calculator, I would enter 1.82 times 18.0. I get 32.76, but I only need 3 sig figs for both of these numbers, so 32.8 grams of water, 32.8. So that is how many grams these moles weigh. So notice what the periodic table is the way to convert between mass in grams and moles. Okay, so up here I had grams and I was going to mole. So the grams were on bottom so that they canceled. Moles were on top. So I ended up dividing by the number on the periodic table. Down here I had moles, and I was changing to grams. So the moles went on bottom, which is always 1 when you're dealing with the periodic table. And those grams went on top. So basically I ended up multiplying by the grams to get grams of water in 1.82 moles. Okay, it's just a conversion unit. It's no different than when we said there's 100 centimeters in a meter. Okay, it's no different than doing that. That is just a conversion unit. Just make sure the 1 always goes with the mole. Okay, if you're using the atomic mass, which is on the periodic table, it is always the 1 goes with the mole. And then the number on the periodic table always goes with your grams. Okay, and if you have grams and you're going to moles, you'll be dividing by the grams to change to moles. If you have moles and you're going to grams, you'll be multiplying by the gram number. But I think if you understand the concept of canceling, okay, so whatever you want to cancel goes on bottom, whatever you want to change to goes on top, then you should be able to set these up relatively easy. The book also gives 3 or 4 really good examples there on page 260, 261, and then also on page 264. Okay, so make sure to use all those examples as well as mine to look at how to set up the problem and how to solve for it. Okay, again, this is very important, and the next one we'll look at the last half of the very last section where we use the mole in chemical equations.